Hello friends and hello student. My name is Ashok Sijala. In this session, we learn the binary to octal number in C language. So first I share my laptop screen and fix the position here so you can watch better my video lecture. And here go C++, I double click and take some process. And now yes, is open Alt F file menu, taking new file, and here our goal, write a program to convert binary to octal number. Yes, so here we can octal number. So yes, in my previous video lecture, I take as a octal to binary number, and here we can binary to octal number, and decimal to binary and binary to decimal. So all that video you have to watch, then you can understand better way in this video lecture. So that is my always technique. What is a first, what is a input, then what is a process, and then what is a output. So divide and conquer in your C any definition to in three parts. So here our binary number, that is our input, and in between how to convert binary to octal, that is our process, and then octal number we have to print, that is our output. So yes, that is a, we have first binary, that is a 0 1, that is a base of 2, and then octal number, so that is 0 to 7, so that is base of 8. And first we can convert the binary to decimal, so decimal 0 to 9, so that is base of 10. So here we actually T number system understand, so we can better way understand this process how to. So you can watch decimal to binary and binary to decimal. So I already take this video lecture as a prepper work, and here I just give one example. So just like we can input 1 1 0 and then 1 0 1, so that is output is 65. So how to convert? So yes, already I take as paperwork in my previously all video lectures. So here I just directly start our coding. So you can actually learn the three number system: binary, octal, and decimal. So first we can binary to decimal number convert, and then decimal to octal number. So that all previous two video lecture you can watch, and then here we can also that understand logic. So now I can start standard input output, that is our header file, and then conio dot h console input output, then void main. And now we can declare some integer variable like first we can octal, so assign to 0, and decimal, so assign to 0, and that two variable, and long, yes, here long integer, two time long long, so that is sufficient range to our binary number. So I assign to 0, and binary we have to scan, so I cannot assign bin any variable, means any value of this variable. So now we can first that our input as a binary number. So enter one binary number, that is our message. And now I can scan a function. So we can use percentage LLD, long integer. So that is 2 time L, and then bin, that is our uh, scan that variable. And now that we can first, yes, here I write comment line. So first we can binary uh, to decimal number. So here can convert this first, and number programming you have to know while loop is the best, because we have to know a starting and ending value. So here we can uh, directly one number, and you can find that number to this number. So here binary to octal. So first that is we can binary to decimal. So yes, bin not equal to 0, and then yes, here we can take as while, and decimal plus equal to, yes. And now we can set that binary, then modulo 10, because decimal that is base of 10, and multiplication power function I can use, and 2 upon I, so 2 raised to I, that is meaning. And we can include one header file, that is a math.h, because that is a hold as a power function, so we can use in our coding. So that is an inbuilt function in math library. I think you have to know very well. So now at I plus plus, so I 0, 2 raised to 0, 2 raised to 1, 2 raised to 2, and then modulo, so that is a separate our digit, yes, in binary number. And then we can that binary number divide equal to 10, so that getting the new number. So that is a, you have to know, plus equal to is a shortcut, decimal equal to decimal, then binary module 10 and power of 2 raised to I. So that all statement, and here I write like a comment line. So binary equal to binary and divide by 10. So that is also compound assignment operator. So yes, that while loop is execute, and we can binary to decimal we can achieve in this while loop. So now that is start second step. So that is our second. So here we can decimal, yes, decimal to octal number. So that is an octal number we have to convert. So I assign to 1, so we can use in our second while loop. So yes, first we can say that decimal not equal to 0. Yes, that is a while loop also. And then you have to know the octal number is a base of 8. So here octal plus equal to, and we can decimal modulo 8, yes, and multiply I. So it is a first time I. So here we can first initialize I 0, and here I initialize 1. Why? Because here multiplication, and multiplication if you assign I 0, so all are 0, but here we can assign the 1. So that is a modulo separate the decimal to digit and multiply I. So that perfectly convert in octal number. And then decimal plus equal to, that is a I 8. So we can get next number, and then we can get that position. So I multiplication equal to, that is our 10. So that is a getting the position of our binary number. So perfectly. So now I can just and now yes, that complete our print. Now that logic is finished, and now that our output, we can say that binary to octal number is yes, and percentage d only, and print the OCT octal number and then get CH. So that is a perfectly. So I save this file. So here we can say that uh, binary to octal. So yes, OCT and dot C. So binary to octal, yes, that perfectly. And now I compile, yes, there is no any error. So our exe file is generated, and let us, we can take this input and we can get as perfectly our output. So here 110 101, yes, and yes 65, that is perfectly. So I already some paperwork, and that is we can get 65, that is a binary number to so that is 65 we have to take as output. So first, yes, let us check as a watch window so you can better understand. So here I give directly not example. So alter W, yes, and take as a watch, and then alter W again, and we can take output window. And now here first we can set the watch window. So here actually that four variables for first OCT, then decimal, then we can take as I, and then in binary. So that is a declaration that take as some student getting the question, we can how to set sequence of in watch window. So that you can follow the declaration order. So first I here declare octal number, so I take octal, then decimal to decimal number, then I, and then again last as a binary number. So that is our input. So you can take as a first, but I follow the declaration order in this watch window. Now I can trace to our logic. So how to, yes, here you can also get one example. We can say that, and here alter R, you have to know trace into F7 function key. I press F7, and you can know every program in C that start in main is our compiling order. So now that you can look here, decimal octal 2 assigned to 0, I assigned to 0, but binary is some garbage value because we have to not initialize. And here that our output, I that clear, yes, and on message enter one binary number. So here I again input 10101. So let us check how it convert to first that binary to decimal number. So I press F7, yes, that go in while loop, yes, not equal to 0, yes, that condition is true. So that is our binary 110101, and then modulo 10 and power of 2 of I. So I initial 0, so that is a 1, and I plus plus, so that is a 1, and new number you can look here 1, that is 1010. So 1 is remove means that is divided by 10. So getting the new number, and again that taking binary is not equal to 0, yes, condition is true while loop, and again decimal store some value I plus plus 2, and then new number, so that is a continue process. So I now 2, and again our while loop is true, decimal that store modulo and 5 you can look, and I plus plus, so that is again 3, and new number, so 110. So again not equal to 0, yes, and then 5, that is same, and because that's 0, so yes, and then I plus plus, so 4, and then again so not equal to, yes, then 21, so that is a power of 10 base, and I plus plus, so divide by 10, yes, and now last, yes, not equal to 0 again. Yes, 53. So that is a binary number, a decimal. We can say that binary to decimal number. So 53, that is answer. And now I plus plus again, but that is now 0, and that all while loop is false. And I initialize again. So I here now again I is 6, so assigned to 1. And now decimal 53 to convert in the octal number. So again that second while loop is start, octal is assigned to 0, and decimal that modulo 8 and multiply I is 1, so that multiply I variable. So yes, here new number, yes, that only 6 I divide by 53, so that is a 6 that taking, and now I multiply 10, so 1 multiply 10, so 10, and decimal not equal to 0, yes, 6, so 6 again that modulo 8, so that is a now modulo is getting 65, our answer is ready, and divide by 8, so 6 divided by 8, so 0, and I, so 100, yes, and now not equal to 0, but decimal is, you have to watch, that is 0, so while loop is finished, and that our answer is ready. So here very easy way we have to find. So I think you have to understand. Yes, you can some paperwork yourself. So then better get the idea. So that is a, now I can enter any like we can say that 101101. So you can say that 135. So that is a taking more while loop, and I is more out of range, that so I take as a long integer. So here there are possibility here, I and then binary is a out of range of integers, so I taking long integer. So in your mind question, why you can take as a long integer I and only binary. So here octal and decimal not required. That is a within the range of our integer data type. But that is a out of range because binary is a long number and I multiply 10. So that is sometimes that is also out of range. So we can uh, previously take the protection to our in the range that value. Otherwise that taking garbage value. So that I take. So I think very simple logic I develop how to convert binary to octal number. So you can watch first my octal to decimal, and decimal to binary, and binary to decimal. So all you can watch my all previously video, so you can get the idea. So yes, I think I hope you can understand and enjoy this session. So any doubt regarding this definition, you can write in comment section. I give the definitely to answer to you. So now you can write this program to your C notebook. Yes, and now I can close Alt F3 function key and watch an output and quit. So subscribe my channel Ashok Sijalakuni. Press the bell icon to never miss any update. And thanks for your watching, supporting, and sharing my video lecture. And Hare Krishna.